Assalamu alaikum wa rahmatullahi wa barakatuh. This is Toyib Ogunremi, and I will be presenting this work on behalf of the co-authors, the Neural Machine Translators as Efficient Forward and Backward Arabic Transliterators. This is a joint work that is accepted at the third Machine Learning Workshop, Muslims in Machine Learning Workshops, co-located with NeurIPS' 2024. So the agenda of our discussion for today is on the following. It will contain all this that was listed here. So the background of this work is that to explore non-Latin writing system, because we found out that there are about 48 commonly used global writing system in the world. And Arabic is a unique one with 28 letters that is written from the right to the left. So translation is a process of converting words or text from one language to the other while maintaining the literal meaning of the original words. While transliteration is a process of converting words or phrase or expression from one writing system to the other writing system, most especially the non-Latin writing system to the Latin writing system or Latin script, while maintaining the sound of the original words. So example is the picture that is image shown here, where we have Bab, Kataba, and Nabil here. So the transliterations of these words in Arabic writing system to Latin writing system is followed here, while the translation, which explain what they mean in both languages, is what we have in the open brackets and the curly brackets under here. So the motivation for this work is to explore the discontinuity between Arabic and other writing systems, like non-Latin. Arabic is a non-Latin, while we compare it with the Latin system. So the other one is to investigate and enhance the ability of non-native Arabic speakers in typing and reading Arabic content. Then the other one is to improve on the findings of authors that found that ROUGE evaluation is very poor on non-Latin scripts. So the other one is that we found out that transliteration is a better approach for non-Latin writing system, because there is a typing ease, since most keyboards offer these letters that are required for transliteration. The other one is that non-Latin languages is easy to learn for foreigners that are already familiar with Latin scripts. The other one is that communication, whereby majority of people use transliteration to communicate worldwide on social media platforms, and most religious knowledge resources now have transliteration embedded into their knowledge box. So these are existing challenges and use case. We can see that this is an Arabic keyboard, which is not usually easy for most people to type in, as we can see that there are even some missing letters in the keyboard that for a user to type, they have to make some other combination of words before they can be able to get there. While this one is trying to bridge the letters in Arabic with the pronunciation of them in Latin system. This is a transliteration of Arabic from Arabic to the Latin system, that is in transliteration, while this one is just the translation in Urdu. And then here we have a popular language learning platform, Duolingo, where we can see a bridge between Arabic letters and their Latin script equivalent. And this is for communication on social media platform, where users try to communicate Arabic using Latin letters or Latin writing system. And this is a religious knowledge box, where we have Quran text being written in their transliteration form to aid non-original Arabic speakers to facilitate their reading. So our contribution is to help in the existing challenges. We saw that there is no there is lack of parallel Arabic romanization script. Most problem where user face is that there is no parallel Arabic transliteration data set to train models to be able to learn the correct mapping or relationship between Arabic letters and non-Latin and their Latin equivalent. Then there is inconsistencies in the representation. In some cases, we found that some letters are represented with different characters, which cause a lot of incontinuity. So the other one is no standard one-to-one mapping or relationship between the letters, Arabic and the Latin characters. And their variability due to dialect and informal usage. Various ways people use their own is different from the way another person uses. So what our own contribution is that we have curated an Arabic and translation script dataset using the Excel sum, which has the Arabic writing system, and we use the uRoman tool to romanize it into the Latin equivalent of those letters. So we propose and develop a proof of concept to show that actually neural machine translators can effectively convert back and forward, whether from Arabic to Latin script or from Latin script to Arabic. And then the other one was to compare the state-of-the-art model performances using the BLEU and ROUGE evaluation metrics. So we are hoping that possibility of a unified keyboard for all languages, because if transliteration is made available, then we can be able to use a single keyboard to type any language. So various related works in this regard are that Chakachiro in 2010 highlights some effect of inconsistencies in romanization practices by saying that it usually affects the preservation of the Arabic letters and Arabic contents. The other one is by Chalabi and Judges, where they built a system to be able to convert from transliterated text into the colloquial Arabic. And M. Jacob developed the uRoman, which is a forward-only romanization tool that converts from Arabic to Latin scripts. So they were trying to make a uniform way that rely on Unicode that converts from Arabic to Latin characters. So where J et al. In 2024 used romanized text as an intermediary when using large language models to learn non-Roman scripts, because they found that they benefit from the shared tokens, since the letters are quite similar to English, and they can benefit from English pre-trained LLMs. So our methodology is that we got the data from the Excel sum, which has the Arabic part, is originally made for summarization, and the pre-processing was done using the uRoman tool that was developed by M. Jacob. And then the training, we fine-tuned 3 HuggingFace machine translation models using the following parameters, and these are the pre-trained language models. So these are our key results. We found out that all the models quite perform well by having a ROUGE score and BLEU score of above 90, and then the difference in the generation length is possibly due to the out-of-the-box vocabularies that the tokenization has, since it's not really familiar with the transliteration as a separate language before. So by analyzing the predictions from the models, we found out that these are some of the mistakes that the misgeneration or the wrong generations in the model. For the Latin, the model quite performed well. Only this was the error that was made, while for Google MT5, which performed poorly on this, this is the worst prediction in generally, as most of the model predicted correctly in 3185 sample out of the 4689 test data set that we evaluated them on. So in conclusion, we hope that this is a uniformed forward and backward transliterator system for Arabic using the NMT, the neural machine translators. And future work will seek to expand this transliteration to cater to full romanization, which involves representing the graphemes and phonemes, because most of the examples that we have found in the data set is that they omitted the the graphemes, like the tonal marks of the letters, because in Arabic we usually have the upper, the middle, and the sukun, the afatiyad, all those marks were omitted. So in a way that would expand, that would cater to all these ones too, would definitely help the Arabic transliteration. Thank you very much.